Alright guys, we're gonna move into solving these two systems of equation using the elimination method. I will use elimination through addition, so that means I'm just gonna add. My goal is to add the top equation by bottom equation. So this will be equation A, this will be equation B. Before I start, I'm gonna look at the A, B, and C. We're gonna look at the coefficient, the number in front of each variable, the number in front of X, number in front of Y, and then C on the other side. Same thing here. I'm going to see if there's any coefficient that is already zero paired or opposites to each other. So we look at equation A, or looking at example A, I notice that this is a positive Y and that's a negative Y. Well, if I were to add these twos together, and I'm going to make the column so you can see it, I'm going to add it. And again, we can only combine like terms. So I'm going to add it left to right in this case. So negative 4x combined with negative 5x is negative 9x. The positive y and the negative y is zeroed out. It's a zero pair. They're opposite of each other. So that's gone. Drop the equal sign. 6 with 21. Add that together. That's 27. So right now this is all I have left if I were to combine the two equations. This is very similar to the whole the squares and the triangles and the circle activity that we did in class. Also the same thing with umbrellas and boots. So now we have negative 9x is equal to 27. We divide both sides by negative 9, and we find out that x is equal to negative 3. And now we just need to use one of the original equations to find y. And I'm going to go ahead and use equation A. Negative 4, instead of writing x, I'm going to substitute in negative 3 because I just found that. Plus y is equal to 6. Well, negative 4 times negative 3 is positive 12, plus y is equal to 6. I subtract 12 from both sides to get y by itself. Y is equal to negative 6. And there's my solution point. But before I move on, I really want to check to make sure that I have the right solution point for both equations. It has to satisfy both equations. So I'm going to go ahead and check it with the equation B. Equation B says negative 5x, and instead of x, I'm going to drop in negative 3 minus, instead of y, I'll write minus negative 6 is equal to 21. And negative 5 times negative 3 is positive 15. Minus a negative 6 is the same thing as adding 6. That's a double negative. 21 does equal 21. So my solution point works for both equations. So that's how you would do something called systems of equation through elimination, through addition. Okay. All right, let's move on to B. Again, before I start, here's my equation A, here's my equation B. I'm going to scan it. I do not see any zero pairs. I don't see anything because this is a negative 5. That's a positive 3x, but you know, they are lined up on the same side. This is a positive 1y, that's a negative 8y. But I do notice that this is a positive y and a negative 8y. Well, wouldn't it be cool if I just zero out the y's? Now you can zero out, you can cancel out. You can eliminate the x, but I'm going to choose to eliminate the y in this case because this is a 1y. So I'm going to multiply. Well, if I wanted to eliminate that negative 8, it has to be a positive 8. So I'm just going to create an equivalent equation using the factor of 8. And I'm going to multiply everything on the inside with positive 8. So here's my new equation A. Negative 5 times 8 is negative 40x. Positive y times 8 is positive 8y is equal to negative 3 times 8 is negative 24. Again, these two equations are equivalent. Rewrite equation B right underneath of it. Split it into my column so I can see it here. I'm going to solve through addition. And here we go. Negative 40x combined with positive 3x is negative 37x. This is gone. Is equal to negative 24 combined with positive 24. Well, that's 0. Here you already know what the answer is for x. Something times negative 37 is equal to 0. Well, the answer is, I'm going to go ahead and do the properties of equality. X is equal to 0. There's my first solution point. Now that I have x is equal to 0, I'm going to go back and solve for y. I will use equation A. Negative 5 instead of x, substitute in 0, plus y is equal to negative 3. Well, 0 plus y is equal to negative 3. That's just y is equal to negative 3. And there's my second solution point, my y value. So I know that it works for the first one. I better check with the second one. 3 times, or 3x, but instead of writing in x, I'm going to substitute in 0. Minus 3 times negative 3 instead of y, because here's that 8y. I'm going to substitute in negative 3 is equal to 24. That's 0. Negative 8 times negative 3 is positive 24, because we're just multiplying those two. 24 does equal 24. So my answer here does work. 0 and negative 3 for x and y. And what we just did is solving systems of equation through the elimination method. We're just creating opposite pairs, and we're going to add them. And if they're not opposite pair, you can actually subtract them, and the same idea works. Make sure that you always check that your solution point works for both equations. Okay, I hope that helped, guys.